Hi, this is Grover with Blue Collar Codes, the Quick and Dirty, episode 27. Going to go over breadth first search and depth first search. Now please note here, I built my own little tree structure. I'm using the binary tree format, meaning it only has 2 children nodes per parent node, a left and a right. But it's not a binary search tree in that it's not maintaining that the left child is less than the current node's parent value and that the right is larger. So this is just going in ascending order. Root is 1, and then 2, 3, 4, 5, 6, 7, and so on. So this is the structure I created. I just created my own node class, and then I built it by hand together. Don't ask me why I like to do this. I think it just continually reminds me of what the structure means, so I like to do it. But I could implement a tree structure or a tree class and make it more self-explanatory or more easier to do, but I do not. That being said, we're going to go over in step-by-step through a breadth first search, and then we'll do a depth first search. But to discuss it verbally first, what it's going to do is for breadth first, we're going to use a queue, and at each element it's going to be adding its 2 children from left to right into the queue. So each time you touch an element, it's going to add the left and the right, and that becomes the continual order. So what ends up happening is it checks this for the value in the search, and in this case I have it searching for the value 12. So it'll first check the root. It'll see 1 is not 12. It'll pass in these 2 nodes, and then it'll pop the second node and pass in these 2 values into the queue to add them up, so that what would remain would be 3, 4, and 5. It's not the value, then it'll go to 3, add 6 and 7, so now the queue at node 3 has 4, 5, 6, 7 left. And so that'll become more apparent as we step through it. But basically using a queue to store all of the nodes, I'm using a while loop for as long as there are nodes, to then loop through the entirety of the tree. So let's get into the visualization here. And so we can see how I added the root node to the queue, and that's the first one. We're going to pop it out, so now the queue is empty. We're going to check the value. It's not the value, so now we're going to add the left node and then the right node. It'll loop back around, and now it's going to pop the next element in the list, the 2 node, and then it'll add, it's not the value, so then it'll add both the nodes to the queue. And so it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 until it finds it. And so that is breadth first search, in that it steps down a level, goes across, step down a level, goes across. Now a depth first search is a bit different in that it jumps as down as deep as it can go and then checks the farthest left and then the right, and then it jumps back up and then checks the right, then the left and the right, and that'll become more apparent as we go through it here. So let me restart this with a breakpoint on the depth first search. And the way that I am implementing this in this DFS method is to utilize recursion and just passing in the left node first. So the first node is the root again, and it finds that it's not the value, so then it goes and it calls the function again, adding in the current node's left reference or left child. Meaning, so we're at 1, it'll pass in 2. It'll find out it's not the value, then pass in 4. Find out it's not the value, pass in 8. And then it'll try to pass in 8's left reference as well, find it none, and that is what actually catches the recursion from diving even further. It stops itself at this if not node, then it returns none. It sees that the result is none, so then it'll traverse to the right and call itself to the right. So we'll visualize that here. So we made it to the 2 node, calling it again. We made it to the 4 node, calling it again. We made it to the 8 node, and just notice the call stack here, as well as the values of the nodes up here. So it's going to try now to pass in the 8th node's left reference, which is none, so it's going to be caught. And then we're going to exit this 5th layer of the call stack and return to the last line that was implemented at the end of it, and then it'll go to the next line, as you'll see here. So it just returned, so it exited that call because it returned none. It's going to see that it returned none here, so that doesn't have a value, and now it's going to go and check the right reference for the 8 node. It's going to find it to be none, and then once it makes it all the way past, that's kind of the end of checking this node 8, and then so it will now return and exit the last stack for the 8 node, and it'll return to the last position executed for the 4 node, which would be right after the left again. There's still only a none result, so now it'll go to the right, and we're at the 9 node. And so I'm not going to go any further in this. You can kind of tell what's going to happen. It traverses all the way down one side, and then when it can't traverse anymore, it checks that node's right side, then goes up a level, checks the right, then the left and the right, goes up, keeps going up to the last call, and then it'll go right, then left, then left. So you imagine this was a lot deeper. It goes, left all the way down. When it finds an end, it tries to go right, and then it goes backtrack, and then it tries to go right, and then left all the way down, and so on and so forth. So hopefully this was beneficial for you. Again, this is Grover with Blue Collar Codes, the quick and dirty. We did breadth first search and depth first search. Thanks for joining.